This video looks at one of the two methods of algebraically solving linear simultaneous equations, the elimination method. Now the step one, if necessary, we have to multiply one or both equations by constants so that the coefficients of one variable in the two equations are the same or opposite. So we need a term to be the same in each of the equations. For example, we have 4x and 4x in both equations, or 4x and negative 4x. We need a term that's the same so we can eliminate it. Step 2, we are going to add or subtract the two equations to eliminate one of the variables and solve. 3, we're going to find the second variable by substituting the one found in step 2 into one of the original equations. And 4, we're going to check the solution by substituting the values into the original equations. So let's look at some examples. In the first one, we have x plus 3y equals 5 and 4x plus 3y equals 11. So you can see that in the two equations, we have 3y and 3y, and they're both positives. So if we number our equations 1 and 2, and we subtract them, the 3y's are going to go away. Now, which equation do we take from the other? We look at the other numbers, the other terms in our equation. So we have 4x and 11, and we have x and 5. The 4x is greater than the x, and the 11 is greater than 5. So looking at that, we'd be better going 2 minus 1. So if it helps you, write the equations out so 2 comes before 1. So we're going to go 2 minus 1. So 4x minus x is 3x, and you'll see 3y minus 3y, it's gone, which was the whole purpose of the elimination method, getting rid of one of the variables. 11 take 5 is 6, so we have 3x equals 6. We divide both sides by 3, so x is 2. We now sub x equals 2 into one of our two equations. Now, equation 1 would be easier because it's got only a single x in it. So we've got x plus 3y equals 5. X is 2, so we're substituting this 2 into there. So we have 2 plus 3y equals 5. So we have 2 plus 3y equals 5. We need to get y on its own, so we're going to take 2 from both sides. So we have 3y equals 3, and then to get y, we're going to divide both sides by 3. So y equals 1. So therefore, solution is x is 2, y is 1. And we can check. So we substituted into equation 1 to find out what y was. So we're going to check into equation 2. So our left-hand side is going to equal 4 times 2 plus 3 times 1. 4 times 2 is 8. 3 times 1 is 3. 8 plus 3 is 11, which equals our right-hand side, so we know we're correct. Now let's look at our next example. So 3x and x, they're different, but we have a positive 5y and a negative 5y. So if we add these two equations, we're going to get rid of our 5y's. So we label our equations 1 and 2, and we're going to go 1 plus 2. And you can just draw a line underneath. You don't have to rewrite your equations. 3x plus x is 4x. 5y plus negative 5y is 5y take 5y, so it's gone. Then we have negative 3 plus 19 is 16. We now divide both sides by 4 to get that x on its own. So x is 4. We now need to find y, so we're going to sub x equals 4 into, I'm going to go equation 2. So I get x minus 5y equals 19. Now it doesn't matter which equation you substitute into, you'll still get the same answer. So 4 minus 5y equals 19. Take 4 from both sides. Negative 5y equals 15. Divide both sides by negative 5. So y is negative 3. So therefore, solution is 4, negative 3. Okay, we can check. Now, second step, we used equation 2. So we're going to use equation 1 to check. So left-hand side equals 3 times by 4 plus 5 times by negative 3. 3 4s are 12. 5 times negative 3 is negative 15. 12 take 15 is negative 3, which equals my right-hand side, so I know I'm correct. Now, this method is easier than the substitution method, or should I say quicker than the substitution method. So if you don't need a rearrange, if you don't have a variable out the front on its own, use the elimination method. Let's look at another 2. Here I have y and 2y, 6x and negative 3x. They're not the same. None of the terms are the same. So I have two options. If I label my equations 1 and 2, I can either go for 2y in both equations, or I could go for the 6x in both equations. It doesn't matter which way you go. Okay, I'm going to go for the 2y, so I'm going to go 1 times by 2. So that becomes y times by 2 is 2y plus 6x times by 2 is 12x equals 9 times by 2 is 18. That now becomes equation 3. So I've got equation 3 and I've got equation 2. They're the two equations I'm dealing with. To eliminate a variable, I'm going to have to subtract. So 3 minus 2. So 2y minus 2y is gone. I now have 12x take negative 3x becomes 12x plus 3x. So that's 15x. 18 take 3 is 15. I then divide both sides by 15. So x is 1. I now sub x equals 1 into, doesn't really matter which equation. Let's go equation 1. So I'll have y plus 6x equals 9. So it's being y plus 6 times 1 equals 9. Y plus 6 equals 9. So y is going to be 3 because I take away that 6 from both sides. So therefore, solution is 1, 3. So alternatively, I could have multiplied equation 2 by 2 and ended up with that 6x in equation 2, and then I would have added my two equations. Okay, either way will work. Let's check. We used equation 1 for my second step, so we're going to use equation 2. So 2y minus 3x equals 3. My left-hand side is going to be 2 lots of 3 minus 3 lots of 1, which is 6 minus 3 is 3, which equals my right-hand side, so I know I'm correct. Last example, label my equations. I don't have anything the same. Okay, I've got 3x and 2x, I've got 2y and 5y. So my goal, I'd either go for 6x or I will go for 10y. Okay, I'm going to choose 6x because I'm going to multiply by smaller numbers. So to get 6x in both, I'm going to have to multiply equation 1 by 2. So that gives me 6x plus 4y equals 36. That's now my equation 3. I then have to multiply equation 2 by 3. So that gives me 6x plus 15y equals 3. So that's equation 4. To eliminate a variable, I can subtract. I can go 3 minus 4. 6x minus 6x is gone. 4y take 15y is minus 11y. 3x take 3 is 33. I then divide both sides by a negative 11 to get that y on its own. So y is negative 3. I then sub y equals negative 3 into one of my equations. I'm going to choose equation 2 because they're smaller numbers. So I've got 2x plus 5y equals 1. 2x plus 5 times negative 3 equals 1. 2x take 15 equals 1. Add 15 to both sides. 2x equals 16. Divide both sides by 2. X equals 8. So therefore, solution is 8 and negative 3. Check. I checked, I did the second part in equation 2, so I'm going to have to do it the equation 1. So left-hand side is going to be 3 lots of 8 plus 2 lots of negative 3. 3 8s are 24. 2 times negative 3 is a negative 6. 24 take 6 is 18. So that is, which equals the right-hand side, so it is correct. So time to practice. Simultaneous equations, one of the most critical things that you learn in maths. You use it for so much problem solving. It is assumed knowledge in mathematical methods. You will also cover it in general. So spend the time to master it.